All right, so today we're going to talk about changes of state. So, this should be kind of a review for you. I know that in the past you've learned about solids, liquids, and gases, and you have previously put together a flip book just to review common states of matter. So, solids are a form of matter that has a definite shape and volume. Liquids are a state of matter that has a definite volume but no definite shape, and a gas is a state of matter with no definite shape or volume. So, today we're going to talk about how those three types of matter can change from one state to another. All right, so vocab that you need to know: freezing, melting, evaporation, deposition, condensation, and sublimation. All right, so let's continue on. All right, so the fact of the matter: what happens when matter changes state? The three most familiar states of matter are what we just went over: solids, liquids, and gases. A change of state is the change of a substance from one physical form to another. So if you look at the diagram on there, you can see a solid going to a liquid going to gas, gas going to a liquid. Those are all changes of state. Okay. When a substance undergoes a physical change, remember we talked chemical and physical changes before, it does not change its identity, just its appearance. So when matter changes state, it's just changing from one form to another. It's still the same thing. So water going from ice to water vapor is just changing its physical. It's a physical change. It's just changing its state. It's still H2O. So it hasn't actually chemically changed. All right, so to change a substance from one state to another, energy must be added or removed. So when a substance gains or loses energy, its temperature will also change. So take a look at the diagram, a solid in the blue on the left. So if we take into account water, because I feel like that's the most familiar thing to us, water going from ice to a liquid water, it's actually increasing its temperature, and it's also increasing the amount of energy its particles have. So the particles actually start to speed up and spread out a little bit, going from ice to a liquid. All right, and then the same thing happens going from a liquid to a gas. So more temperature added, more energy added, more movement of the particles. Okay. All matter is made up of tiny particles in constant motion. During a change of state, the motion of the particles changes. So, just kind of like what I said, here it's more represented by a gas. The particles are moving all over the place, they're bouncing off the walls, there's no definite volume, there's no definite shape they're taking, they're just bouncing off each other. They'll start to slow, and we're talking about a liquid, and then really hardly moving at all when we're talking about a solid. All right, as they gain or lose energies, particles can break away from each other and gain more freedom to move, and they may attract each other more strongly and have less freedom to move. So, again, just what I just said on the other slide: going from a solid to a liquid to a gas, more freedom to move. Okay. All right. During a change of state, a substance gains energy or loses energy to the environment. So when we say gain or lose, we're not really meaning it's lost or gone forever, because the law of conservation of energy says that energy is never lost or created. It's just changed. So it goes from one type to another. So when we change state from solid to liquid to gas, we're adding energy, but the energy isn't just appearing, it's being pulled from the environment somewhere. And the same goes to going from a gas to a liquid to a solid. It's actually losing that energy to the environment. All right. When we change from a liquid to a solid, so think water going from liquid water to solid ice, that's called freezing. When a liquid is cooled, its particles have less energy, all right, and then they slow down, going from a liquid to solid, and they lock into a fixed arrangement. That's a solid. All right. The temperature at which a liquid substance changes to a solid, so when we have water changing to ice, is the freezing point. All right, when a solid is warmed, so think going from ice back to water, the particles gain energy, speed up, and the attraction between them decreases, so there's more particle motion. Eventually, they just slide past each other. So in a solid, they're more fixed. They're just kind of maybe like vibrating there. There's not much going on. But then liquid, we start to gain energy and move around. All right. The change of state from a solid back to a liquid is melting. So think ice melting back into water. The temperature at which a substance changes from a solid to a liquid is called its melting point. All right. As a liquid is warmed, its particles gain energy. So think like warming a pot of water on the stove. So as it's warmed, some particles will gain enough energy that they escape from the surface of the liquid and become a gas. So you can think of a boiling pot of water. Some of that escapes as water vapor. It looks like steam. All right, the point where the water starts to move into steam is called evaporation, and that actually happens in our atmosphere all the time. So anytime you have a large body of water or any body of water and it gets warmed up from the sun, especially in warmer climates, that's why they get so much rain. Warmer climates, the water evaporates, it goes into the air, it cools, and then it comes back down. So that's called evaporation. When a liquid is evaporated and it turns into a gas. So that's evaporation. Liquid going to gas. So water going to water vapor. All right. A rapid change from a liquid to a gas. So think boiling a pot of water. That's the boiling. That specific temperature when it hits that specific temperature that it hits when it starts to boil is the boiling point. All right. As a gas is cooled, its particles start to slow down and lose energy to the environment. The attraction between the particles overcomes their motion and a liquid will form. So it goes from this high energy gas to a slower liquid. All right. The change of state from a gas, so think like water vapor, to a liquid is called condensation. So if you think when you boil water and you see that water, maybe you put a lid on the boiling water, you'll see that water will collect on the top of the lid, and that's condensation. So what was happening was the water was boiling, turned into water vapor, but then as it hit that lid, it cooled and then turned back into water. So that's called condensation. All right, under the right conditions, and this is fun, some solids can change into a gas without ever becoming a liquid, and that's called sublimation. So skipping a phase, going right from a solid to a gas, sublimation. And we can use nitrogen to take like a solid cream and turn it into a gas. So sublimation can occur. All right, on the opposite end, going from a gas to a solid is called deposition. So skipping the whole liquid phase altogether. All right, so again, this is what we've said before. When matter changes from one state to another, its physical state changes, but its identity does not. So water might go from being ice to liquid water to water vapor, but it's still H2O. It's not chemically different at all. All right. And then during a change of state, the energy of the particles, their movement, and the distance between them change. So again, look at the diagram. Solids fixed in place, very little movement, little bit of energy. Then as you gain energy, gain temperatures or heat, then you're starting to get more particle motion, more energy. Then, as you change from a liquid to a gas, they're bumping all over each other. We got more energy, more heat. There, we're at a gas. All right. And then, if you were to look at the law of conservation of matter again, when you have in an environment where no energy can escape to the environment, so in these boxes represented in the diagram, that's like a vacuum sealed box, 10 grams of solid ice will melt into exactly 10 grams of liquid water. So, assuming there's no environment for it to transfer to, the law of conservation of matter says it's not lost or destroyed. It's just transferred. So 10 grams of ice equals 10 grams of liquid water. All right, kids, so make sure you filled in your notes and that you have everything completed. Please, please, please let me know if you have any questions, and we'll go from here. Thanks.